We are discussing the chapter control and coordination. In this chapter, we have discussed certain terms: what is control, what is coordination, what is stimuli, what is response, how the plants control and coordinate their responses, their activities, their growth and developmental activities. And after that, we have discussed the various plant hormones. The 5 major plant hormones are auxin, gibberellins, cytokinin, abscisic acid and ethylene. After that, we have to discuss the tropic movements, which are also known as tropisms. What are tropisms? Tropisms are the directional growth movements of a plant part in response to a stimuli. The term which is very important in this definition is directional growth movements. Why they are known as directional? Because the tropisms, the response in case of tropisms depends on the direction of stimuli. The direction of stimuli will decide the direction of response. Whether the direction of response is either in the direction or against the direction of stimuli. So the tropisms are further subdivided into 2 forms: positive tropisms and negative tropisms. What are positive tropisms? If direction of stimuli and response are towards each other. Then those kind of tropic movements are known as positive tropisms or positive tropic movements. What are the negative tropisms? When the direction of response of a plant part is opposite to the direction of stimuli. Types of tropisms. There are in total 5 types of tropisms on the basis of stimuli. First is phototropism. Photo means light. The directional growth movement of a plant part in response to light as a stimuli is known as a phototropism. Second is geotropism. Geo means Earth's gravitational force, which is known as gravity. The directional growth movement of a plant part in response to gravity is known as geotropism. Third, hydrotropism. Hydro means water. The directional growth movement of a plant part is either in the direction or opposite to the direction of stimuli is known as hydrotropism, and that stimuli in that case is water. The fourth one is thigmotropism. Thigmo means touch. The directional growth movement of a plant part in response to a touch as a stimuli is known as thigmotropism. And the fifth and the last form of tropism is chemotropism. The directional growth movement of a plant part in response to a chemical is known as chemotropism. These 5 tropisms are in detail and we'll discuss them one by one. First we'll discuss phototropism. Photo means light. Directional growth movement of a plant part in response to light as a stimuli is known as phototropism. The plant shows a directional growth movement in response to light, and that type of tropic movement is known as phototropism. The phototropic parts are of two types. First, positive phototropic, and second one is negative phototropic. The parts which move towards the stimuli are known as positive phototropic. Example, shoot. Stem moves towards the sunlight, so it is positive phototropic. And roots moves away from the sunlight, they are negative phototropic. अच्छा, जो स्टेम है वो सनलाइट की तरफ जाती है, तो सनलाइट जो है वो लाइट जो है वो फोटो या स्टिमुलाई है, and the growth of the stem is towards the sunlight, so this is positive phototropic. But the roots always go away from the light, away from the sunlight, those are negative phototropic. So these are the certain activities. There are certain activities which shows positive phototropic movement of shoots. How? Take a potted plant, place that potted plant near a window. After some time we observe that the shoot of this potted plant bends towards the window. Here the shoot is going straight, directly in the upward direction, but when we place it near a window, then the shoot bends itself towards the sunlight. This activity shows that shoot or stem is positive phototropic. Now we will discuss activity and a very important question for your board exam, that why do shoot or stem bends towards the light? The physiology of it. In the bending of shoot towards the light, a plant hormone that is auxin plays a very important role. We had discussed this topic in a very short form in the plant hormones as well. हमने पढ़ा था बच्चों की प्लांट हार्मोन जो है ऑक्सिन, वो शूट को हेल्प करता है किस चीज में? फोटोट्रोपिज्म शो करने में. How it helps? Let us consider it's a shoot. When the sun is overhead, just above the shoot, the auxin present in the shoot is evenly distributed. The plant hormone auxin is evenly distributed and sun is overhead. But as we all know, bache, the position of sun with respect to plant keeps on changing as earth keep on rotating around the sun. धीरे धीरे sun की position earth के respect में change हो जाएगी. So when the sun shifts is placed with respect to earth, this situation arises. What is that? Sun comes on that side. Suppose this auxin will prefers to remain in shade. Auxin will shift towards the region that is opposite to the light, that is in shady region. पहले बच्चे क्या था? सन वाज ओवरहेड, सन बिल्कुल ऊपर था तो सब जगह बराबर लाइट आ रही थी, तो क्या था? ऑक्सीजन इवनली डिस्ट्रीब्यूटेड था, इक्वली डिस्ट्रीब्यूटेड था पूरी शूट में. अब क्या हुआ बच्चों? सन जो है वो एक साइड पर हो गया. नाउ सनलाइट इज कमिंग फ्रॉम दैट साइड. सो दिस इज द एक्सपोज्ड पार्ट एंड दिस वन इज द पार्ट, द रीजन विच इज इन शेड, जो छाया में है. ऑक्सीजन tends to go in the shady part ऑक्सीजन शेडी पार्ट में जाएगा, ऑक्सीजन प्रेफर करता है शेडी पार्ट में जाना, तो ऑक्सीजन इज कलेक्टेड इन द शेडी पार्ट एंड ऑक्सीजन इज अ ग्रोथ प्रमोटर। ग्रोथ प्रमोटर है बच्चे, तो इस पार्ट की ग्रोथ ज्यादा होगी और इस पार्ट की ग्रोथ कम। ड्यू टू दैट अनइवन ग्रोथ द स्टेम bends towards the sunlight. So, due to uneven growth, what do you mean by uneven growth? The growth on the one side where oxygen is collected is more, obviously, which growth promoter है oxygen, तो ऑक्सीजन जिस तरफ ज्यादा होगा उस तरफ ग्रोथ ज्यादा होगी, जिस तरफ ऑक्सीजन कम होगा उस तरफ ग्रोथ कम होगी। ड्यू टू दिस अनइवन ग्रोथ द शूट बेंड्स टुवर्ड्स सनलाइट। अ वेरी इंपॉर्टेंट डायग्रामेटिक बेस्ड क्वेश्चन फॉर योर बोर्ड एग्जाम। सन इज प्रेजेंट ऑन दिस साइड। A very, very important question. This is just a diagram. You have to write certain statements as well. In the statements, you just write the same thing which I explained to you. That when sun is present overhead, the oxygen is evenly distributed in the shoot. But when the position of plant with respect to sun is changed due to rotation of earth, the oxygen will tends to remain in the shady part, tends to collected in the shady part. As oxygen is a growth promoter, the oxygen-rich region has more growth, and the region which is other than the oxygen is show less growth or is having the less growth. Due to that uneven growth, the shoot will bend towards the sunlight, and that is known as positive phototropic. Next tropism we have to discuss is geotropism. Geo means gravity, the earth's gravitational force. The directional growth movement of a plant part in response to gravity is known as geotropic. The parts which moves towards the gravity are known as positive geotropic. Example, roots. As we all know, roots moves towards the gravity. They move towards the center of earth in the downward direction. So roots are positive geotropic and stems are negative geotropic. Stems always moves away from the gravity. So the plant parts which moves towards the gravity are known as positive geotropic, and the plant parts which moves away from the gravity are known as negative geotropic. Now we'll discuss an activity regarding the geotropism. For this activity, we have to take a potted plant as it shows. This is a potted plant, bache. The roots are moving towards gravity and stem is moving away from the gravity, so they are showing positive and negative geotropic. What should we do is, we have to tilt this pot. Give the water to the pot on the alternative days. After some days, you will observe that the stem moves away from the gravity and root moves towards the gravity. The straight stem has a bending now. So this bend in the stem shows that this bend occurs because of the because of the negative geotropism of shoot. As shoot bends away from the gravity. And the roots moves towards gravity. So this activity proves geotropism. What is happening in this activity, bache? I'm explaining you again that initially we take a potted plant. The plant is upright, straight. The stem is moving away from the gravity and the roots are moving towards the gravity. But we tilt it. We tilt the plant and place the pot as it is in the tilted position. Then we observed that the stem has a bend in between and the stem will start to move away from the gravity, whereas the roots has a bend and it will start to move towards the center of earth. So this activity will prove that shoot or stem is negative geotropic and root is positive geotropic. Third tropism is hydrotropism. The tropic movement is a directional growth movement in which the plant part shows a response to water as a stimuli is known as hydrotropism. It is a tropic movement in which the plant shows a directional growth movement in response to water, and that is known as hydrotropism. The parts which moves towards the water are positive hydrotropic, and the parts which moves away from the water are negative hydrotropic. वो parts बच्चे जो पानी की तरफ जाते हैं positive hydrotropic हैं, और जो पानी से दूर जाते हैं वो negative hydrotropic. And roots always move towards water, and shoots always moves away from the water. दो है बच्चे, roots जो है वो water की तरफ जाती हैं हमेशा नीचे की ओर, gravity की तरफ भी और water की तरफ भी. तो roots are positive geotropic as well as positive hydrotropic. Whereas shoot always moves away from the gravity as well as away from the water. So shoots are negative geotropic as well as negative hydrotropic. Now we'll discuss activities related to hydrotropism. The first activity is activity regarding the germinating seeds. In the next chapter of biology, that is how do organisms reproduce, you will study that when seeds germinate, when seeds will start to grow into a plant, they will grow a white color structure, white thread-like structure known as a radicle. And that radicle which will become future root. तुम पढ़ोगे बच्चे हाउ डू ऑर्गेनिज्म रिप्रोड्यूस में कि जब एक सीड उगना शुरू होता है ना बच्चे, जब एक सीड जर्मिनेट होना शुरू होता है तो उस सीड से एक थ्रेड-लाइक स्ट्रक्चर बनती है, उस स्ट्रक्चर का नाम है रेडिकल. And that radical will later on grows into a root. और वो radical आगे चलकर क्या बनने वाला है? Root बनने वाला है बच्चे. So radical means root. In this, what we have to do is we'll take a sieve tube. We'll take a sieve-like wire mesh. Place some moist sawdust over it. Sawdust means लकड़ी का बुरादा. Moist sawdust रखेंगे. Moist sawdust क्यों लेंगे? Because it keep on containing the moisture for a longer period of time. Then we place germinating seeds in it. क्या करेंगे हम? Germinating seeds रखते हैं. We'll observe that first the radical will starts to grow and move towards the gravity. हम देखेंगे पहले radical grow होने लगेगा, जैसे उसे moisture मिलेगा बच्चे, seeds जो है वो उगने लगेंगे और radical grow होने लगेगा and it will starts to move downward. But after some time, after some growth, it will bend towards water. And radical is future root. This activity will prove that roots are positive hydrotropic. What happens basically is when we place certain germinating seeds in sawdust, in moist sawdust, then those seeds will tend to give rise a radical, future root. The radical first grows in the downward direction due to gravity, but after some growth they'll bend and move towards the moist sawdust which has a water in it. This activity will prove that roots are positive hydrotropic. Next activities. Take a wide container. Fill it with the soil. It is a plant in it. We'll observe that root will move downwards towards water. The whole soil is moist. And the shoot will move away. This is the first case. In second case, what we should do is, we have to fill this wide container with dry soil. In this, the moist soil is being taken, and in the B container, take the dry soil. Fix a plant at one corner, and at the other corner, place a earthen pot or an earthen container. Earthen container means which is made up of clay soil and has pores in it. Fill it with water. But we will observe that it will seep out the water and make this soil moist. On this side the soil is dry, on this side the soil is dry, but on this side, due to the water present in the earthen pot, the soil will become moist. हम देखेंगे बच्चे कि ये पूरी सॉइल पहले ड्राई थी, बट जैसे हमने अर्दन पॉट इसमें डाला, एक ये कहो कि मटका डाल दिया इसमें या कोई एक पॉट डाल दिया सिंपल जो फ्लावरिंग पॉट है, उसमें पानी भर दिया, हम देखेंगे बच्चे पानी सीप आउट होगा और इधर की मिट्टी गीली हो जाएगी. The soil present on the other side will become moist. After some time, we observe that the roots will tend to move that moisture side. Roots bend towards water. So this activity also proves the positive hydrotropism of roots. Next tropism, which we are going to discuss, is Thigmotropism. Thigmo means touch. That means the directional growth movement of a plant part in response to touch as a stimuli is known as thigmotropism. Whensoever a plant part responds to a touch and that movement is a directional growth movement, that is known as thigmotropism. So in thigmotropism, the stimuli is a touch. Example is climbing of a tendril. Suppose this is the support and there is a plant whose tendril tends to climb around it. So that is the tendril which is climbing around it. Suppose this is the support, that tendril climbs over it, around it. That is the example of thigmotropism. How it is thigmotropism? The part which is in the direct contact, this part, this has less growth, and the part which is away, this part, this outer part, has more growth. The oxygen concentration shifts towards the outer region which is away from the touch. Suppose this finger is a tendril. This part is to be climbed over here only, like this. This part is the internal part which is to be comes into contact with the support, and this part is the outer part. So in the outer part of this portion, the oxygen concentration is more, whereas in the inner part the oxygen concentration is less. So the part which is in the direct contact has less oxygen concentration. This is the part which is in direct contact, and it has less oxygen concentration. Less oxygen means less growth, because oxygen is a growth promoter. But this outer part which is away from the touch has more oxygen, and more oxygen means more growth. Due to that more growth, tendrils tends to climb in the upward direction and around a support. The last tropic movement of your class 10 syllabus is chemotropism. Chemo means chemical. The directional growth movement of a plant part in response to a chemical is known as chemotropism. Whenever a plant part moves in the direction of a chemical, that is known as positive chemotropic, and if a plant part moves away from it, that is known as negative chemotropism. The example of chemotropism is growth of pollen tube is due to release of a chemical at the stigma. In the same chapter, how do organisms reproduce, in the next chapter of biology, you'll study the structure of female reproductive part, that is carp. This part is stigma, this part is style, and this swollen part is ovary. Ovary has the embryo sac which has egg in it. Egg means female gamete. When pollen grain, the male gamete falls over it. It contains male nuclei and the female nuclei is here. So a tube will starts from this. A tube will originated from this pollen grain. And the growth of this tube is initiated by a chemical which is released by stigma. That chemical is inositol sugar complex. Basically, that is a carbon, boron and oxygen rich sugar complex which tends to initiate the initiation of pollen tube from the pollen grain. Do not go in that much detail. Just learn the example very carefully. It's a very important question for your board exam. What is the example of chemotropism? How in plants the reproduction is maintained, or the reproduction is completed by the help of chemotropism? So the answer is the growth of pollen tube from the pollen grain, so that the gamete, the nuclei, the male nuclei can reach up to the egg, is due to the chemotropism. So the growth of pollen tube from pollen grain when pollen lies on stigma is because of a chemical, and that is known as chemotropism.